Hello guys, welcome back to this YouTube channel. So today we'll be looking at exact differential equation. Before I continue, I would like you to subscribe to this YouTube channel and don't forget to click the notification bell to get notified for upcoming videos. Now, from our previous videos, we treated partial differential equation, ordinary differential equation, homogeneous equation, and we've solved examples on it. So let's now continue from exact differential equation. Now recall that our a of x comma y dx plus b of x comma y dy equals 0. This is an homogeneous equation and it is a first order differential equation. First order. Okay, so this can also be written as a of x comma y dx plus b of x comma y dy equals, instead of putting 0, we'll now put du. You can rewrite it this way, and I would like to call this my equation 1. Take notes. Like I said in the previous video about a differential equation, I said a differential equation must have the dependent variable, an independent variable, and its derivative. So when you are differentiating the given equation, you differentiate with respect to x and you also differentiate with respect to y. So let's say our du now will be equals du because it's a partial differentiation, so we have du dx dx plus du dy dy. So I'll call this my equation 2. It's a partial differentiation. You differentiate x, then you differentiate y for you to differ because the two are in the equation. Now if you notice, you see that from our equation 1 we have du, and also from our equation 2 we also have du. So this simply means our du from equation 1 and equation 2, our du is equal to du. So for equation 1 we have our du to be a of x comma y dx plus b of x comma y dy equals, our du for the second equation is du dx dx plus du dy dy. Okay, now because of the equality sign here, we can equate like terms. Let me use the word. What are the like terms here? For this first one that has the x, then for the right hand side we also have the other one that has the x, so they are the like terms. You bring them together. So that simply means, this implies that our a of x comma y dx is equal to du over dx dx. So our dx can cancel dx and we'll be left with a of x comma y dx. Okay, no, the x is cancelled out, so we don't have the x again, equals du over dx. So let's take note of this. For the second one, we have our b of x to be b of x is equals this b of x comma y die y now is equals dy die u over die y dy. So this our dy also cancel dy and we'll be left with b of x comma y equals die u over die y. Also take note of this. We can now continue. From our continuous function with derivative of order 2, that means we want to differentiate u twice, order 2. You agree with me that our die square u over die x, you differentiate with respect to x and you differentiate with respect to y, is the same thing as you saying die square u over differentiate with respect to y first and differentiate with respect to x. You get exactly the same thing. And this is also equal to you saying you bring out die over die x. If you remove die over die x, you'll be left with die u over die y equals, here you bring out die over die y, you'll be left with die u over die x. Okay, then let's continue. We have our die x. From our earlier solution, we solved our die u die y to be b of x comma y. So anywhere we see die u die y, we replace with what? B of x comma y. So here you can put your b of x comma y equals our die y. We solve it to be a of x comma y die x. Our du die x is a of x comma y. Okay, so our final answer here. So we have our final answer to be die b over die x equals die a over die y. Well, you can write this in any way. You can say it's the same thing as die a die y equals die b die x. So that's the end of this video. This is actually the necessary condition. We call this the necessary condition, or you can say the sufficient condition for a differential equation to be exact. Yes, before you solve any differential equation, you have to check if it is exact, and this is the method you follow to check it. Thank you for watching this video. So don't forget to subscribe and click the notification bell to get notified for upcoming videos.